Oftentimes, balancing a redox reaction by observation is nearly impossible. That is why you have to assign oxidation numbers to see how electrons are transferred or how many electrons are transferred. That makes balancing the redox reaction a lot easier, especially if you follow these steps. So we're going to assign oxidation numbers to every element in this reaction, and it's going to help us balance the equation. You have to use this method if you have a total balanced equation. If you have a net ionic equation, you can use the half reaction method, which you don't have to assign oxidation numbers for, but we'll talk about those in another video. So let's start by assigning oxidation numbers to all the elements here in this reaction. Oxygen is a -2. We need the molecule to be neutral overall, so we have a -8 charge from the 4 oxygens. Sodium is in group 1, so we know it is a +1 oxidation state. So then we can determine that chlorine, in order to get the molecule to equal 0, must be a +7 oxidation state. We can find the oxidation state of chromium, knowing OH is OH minus hydroxide ion. If you needed 2 of those, that means chromium must be Cr2+, so the oxidation state must be 2+. Oxygen in CrOH2 would be -2, hydrogen would be +1. Hydrogen is also +1 in water, and oxygen is -2 in water. In NaCl, you only have 2 elements, so you can just look at what group they're in the periodic table. Sodium is in group 1, so it has a +1 oxidation state. Chlorine is in group 7, so it has a -1 oxidation state. And then we have CrOH3. Once again, we know OH minus. If you needed 3 of those, then it must be Cr3+. Once again, oxygen would be a -2 and hydrogen a +1. So now that you have the oxidation numbers assigned, you can look for the substance that is oxidized and the substance that is reduced. You got to have one of each. So if we look here, chlorine changes oxidation number from +7 to -1. The only way to go from a +7 to a -1 is to reduce your oxidation number. That is reduction. And in this case, we had to gain 8 electrons in order to go from +7 to a -1. If you look at chromium, chromium went from a +2 oxidation state to a +3 oxidation state. It has lost an electron. So it is being oxidized. It loses 1 electron. So what we've done here is step 1. And we've also done step 2. We placed a bracket to the atoms that show an oxidation number change. So now we're going to go to step 3. The number of electrons lost must equal the number of electrons gained. Use the least common multiple for this. The numbers you multiply by become the coefficients in the equation. So we have least common multiple of 1 and 8 would be 8. So I'm going to multiply the reduction half reaction by 1 and the oxidation half reaction by 8. So what this means is that we're going to put a 1 as the coefficient in front of the 2 substances connected by the reduction bracket. We're going to put an 8 in front of the 2 substances connected by the oxidation bracket. So we're going to put a 1 in front of NaClO4 and NaCl. We're going to put an 8 in front of CrOH2 and CrOH3. When we do this, about 99% of the time, the coefficients of the products are not going to change. So I'm going to circle those and just indicate that those are not going to change. You're still going to want to balance everything by observation to make sure. These numbers, the 1 and the 8 we put on the reactant side, could possibly change. In this example, they happen to not change. The only thing we have to do to finish this is determine the coefficient in front of H2O. I'm going to balance the hydrogens. If you look on the product side, you can see we have 3 hydrogens in every hydroxide, and then we have 8 hydroxides. So we have 24 hydrogens on the product side. We have to have 24 on the reactant side. Here we have 16 hydrogens from CrOH2, which means we need 8 more hydrogens. That means we must put a 4 in front of the H2O to get your 8 more hydrogen. If you check the oxygens, they are also balanced. So this is the balanced redox equation using the ElectronTransfer method. Let's look at the questions regarding this reaction. What substance was oxidized Be specific. Well, look at the oxidation bracket where it starts. You have chromium 2 plus in CrOH2 that was oxidized. What substance was reduced? Once again, look at the reduction reaction where it starts. Cl plus 7 in NaClO4 was reduced. How many electrons did each chlorine end up with? Chlorine has an atomic number of 17. That means it has 17 protons, but it also means it has 17 electrons. So end up with means look at chlorine on the product side. Well, it is a -1. So chlorine goes from Cl and ends up as Cl minus. It had to gain an electron. So if it has 17 electrons normally and it gains an electron, well, that means it ends up with 18 electrons. How many electrons did each chromium start with? Chromium has an atomic number of 24, which means it has 24 protons and 24 electrons. Well, start with means on the reactant side. So look at the reactant side. Chromium is a +2. So chromium starts as +2. Well, to get a +2 charge, it has to lose 2 electrons. So if we take 24 minus 2, for the 2 electrons it lost, we get 22 electrons. And then one thing that makes these a little bit easier for me to grade is just sum up the coefficients, and I can tell if you pretty much got it right. In this case, 8 plus 1 plus 4 plus 1 plus 8 is 22. We're going to speed this example up a little bit. I assigned the oxidation numbers, and you can see after doing that oxygen goes from a +2 to a +3 oxidation state. It had to lose 1 electron to do that, so iron is being oxidized. Nitrogen is being reduced. It goes from +5 to +2. Its oxidation number is decreasing. So from here we can balance this. We need to, first of all, balance the electrons. So we need a least common multiple of 3 and 1. That would be 3. So we're going to multiply the reduction reaction by 1, the oxidation reaction by 3, and we have 3 electrons that are being transferred. So that means we're going to put a 1 in front of the substances connected by the reduction bracket, and a 3 in front of the substances connected by the oxidation bracket. So there's the 3's, and here are the 1's. Right? The coefficients on the product side are not going to change, but the coefficients on the reactant side just might. If you look, for instance, at the irons, you have 3 irons on the reactant side, and you have 3 irons on the product side. Those are fine. But if you look at the nitrogens, you have 6 nitrogens here in FeNO3 and then 1 more in HNO3 for a total of 7. But over here, you have 9 nitrogens in FeNO3 and then 1 more in NO. So you have 10 nitrogens on the product side. So you have to balance the nitrogens on the reactant side. In this case, we have to change the 1 in front of HNO3 to a 4. We're going to change that one because if we change the 3 in front of the iron, well, that would mess up the irons and you'd have to go back and change this one. And we know we can't change the product coefficients. So 4 HNO3s. And that allows us to balance H2O. We can see we have 4 hydrogens here on the reactant side. So we need 4 hydrogens on the product side, which means we need 2 H2Os. If you check the oxygens, they are balanced. All right, so what substance was oxidized? Be specific. In this case, it's Fe2 plus in FeNO3 What substance was reduced? Well, that was the nitrogen plus 5 in HNO3. How many electrons did each iron end up with? Well, iron as a product is +3. So in order for iron to go to +3, it had to lose 3 electrons. So we're going to take 26 electrons that it has in a neutral atom minus 3 electrons, and it ends up with 23 electrons. How many electrons did each nitrogen start with? As a reactant, nitrogen is a +5. So that means it had to lose 5 electrons to go from nitrogen to nitrogen +5. So we take the 7 electrons it normally has in the neutral atom, subtract 5, and we get 2 electrons. That's how many electrons nitrogen starts with. The sum of the coefficients in this equation happens to be 13. All right, you try to balance this equation on your own. Don't worry about the questions here. Just try to balance this equation and see how you do. When you think you got it, press play to check your answers.